Today, I want to talk about UV, which is a tool I actually discovered very recently. It's not a very old tool, to be honest. It was launched in February 2024, but I discovered it when I was putting together a course on deep learning with JAX that required a lot of packages and a Python version that was different from the one that I used for my computer in general. And I was so impressed that I decided it was really worth mentioning it to other people. So Python is notorious for being potentially very messy when it comes to versions and package management. And I think this little XKCD cartoon is really representative of a lot of everybody's struggles, because Python is needed by your computer as a dependency to run a bazillion software, because Python is not just a language for scientific computing, but also a general language that is used for software development. So you have at least one Python version to run a lot of the software on your machine, potentially more than one. And that can be managed by your Linux distribution package manager or Homebrew or some installers for one software or another that you have run. And then there are the Python packages that you install, and maybe you use Conda or Anaconda, maybe you've used PyEnv, maybe you've used something else. And then, of course, excuse me, Python doesn't come with an integrated package manager the way R or Julia or other languages come. Like in R or Julia, you can manage your packages directly from within R or Julia. There is no such thing in Python, so you have to rely from external tools to manage your packages. And so, again, some people will use Conda or Anaconda. A lot of people will use Pip. And then a lot of people have been using packages over time. And so the situation, the context before UV came along really looked like this. So this is a list of all of the Python packages or other packages, because some of them, like Conda, are not Python packages per se. They're just a list of software that are used to manage Python environments and versions and packages. And the list goes on and on and on. And some are very popular, some less so. Some have fallen out of fashion. So there is Pip, of course, the big classic, and kind of like the official Python package manager. But there's also Pip tools, PipEnv, PipX, Poetry, which was very popular at one point, and then there's PyEnv and PyFlow and PyInstaller and PyThis and PyThat and PySomething else, and the list really goes on and on. And so it's really confusing when you start learning Python to figure out what to use, and recommendations keep changing because nobody is very satisfied by the state of things. And so every few years, someone comes along and wants to fix the system by creating the one better tool that's going to really solve all this mess. And that tool gets a little bit of traction, can be more or less good, more or less well documented, and then it just adds to the mess because it doesn't become universal, and it's yet one more tool that gets added. But of late, Rust has really become fashionable, and I would say for good reason. So yes, people brag about their utilities written in Rust, and like the classic joke is, how do you know that a tool uses Rust? Well, they will tell you. And it's true that if you go on GitHub and you look at modern tools, they tend to use Rust, and they are always advertised as using Rust. But it is a good thing because Rust is indeed very fast, and those modern utilities are usually much, much faster than the other utilities that they tend to replace. And over the past year, I have really thrown in the trash a ton of utilities of all kinds that I had been using for a long time and replaced them by modern equivalents that use Rust and that are, yeah, very fast. And so in this age of Rust, UV was created, and it is not the official tool by any means. It's still very young. The user base is really growing very, very fast. It has a ton of stars on GitHub, but hopefully it will not be yet one more tool that will add to the mess. I have hope that it will actually sometimes make a difference, and it intends to be universal in that it replaces all of those PyThis and PyThat, and you can use it to manage Python projects and virtual environments and packages and you name it. So of course, the Rust thing is really fast. It's also excellent to resolve dependencies, which pip is not really good. You might have encountered issues when you try to install a number of packages with pip that pip tells you, well, okay, well, there's nothing we can do about it, or well, we don't read this, but like be aware that pip is not officially capable of resolving dependency conflicts. So pubgrub, which you guessed it, is written in Rust, runs under the hood and is used by UV and is actually really fast to resolve all that. And then also UV uses a cache, a global cache on your user profile, and that allows you to reduce dependency deduplication, because if you use if a number of Python dependencies are used in a lot of your virtual environments, instead of being reinstalled in all the virtual environments, taking a lot of unnecessary space, everything will be in that cache. So of course, that will speed things up whenever you reuse any of these dependencies, but it also saves you from having things installed a million times everywhere. Now, one thing that kind of narrows the bounds of UV is that UV is really a Python tool. So if you have pipelines that involve a lot of Python and non-Python dependencies, then you might still want to look at Conda or other tools that will allow you to deal with your Python and non-Python dependencies. There are tools that are now being built and make use of UV to expand UV beyond the Python world, but this is beyond the scope of this talk. And so UV is fantastic, I think, for everything that has to do with Python, but it only deals with Python and Python dependencies. Now, a big warning before I jump into the material: do not use UV on the Alliance clusters. Everything I'm going to show you and teach you in this webinar, I want this to be very clear, is for your local computer. So just a little recap before I get into UV to make this very clear. If you use the Alliance clusters to use one or another of Python versions, you have to use the module system. This is how the clusters are set up. Don't mess around with UV, use the classic module system. So you can list available Python versions with module spider Python. You can check how to install a specific Python version with module spider and that specific version. And you can load a particular Python version with module load. So that's the classic stuff, stick with it. And similarly on the Alliance clusters, I'm sure you've been warned not to use Conda or even worse, Anaconda. Well, also don't use UV for your packages. So if you really need a lot of Python and non-Python dependencies, something that Conda is good at, but cannot be handled by pip, then look at containers, look at other ways to go about it, but don't use Anaconda. And similarly, don't use UV. So on the Alliance clusters, you create a Python virtual environment, you activate it, you update Pip and note the no index flag that makes use of the wheels that have been built on the clusters and that are optimized for the hardware that we have. And so that will not only save you a lot of time during the installation, but it will also optimize everything for the hardware. And then install with pip install, and again, no index to use wheels as much as possible, and then your packages. And if wheels don't exist, then the Python packages will be used from the Python package index, PyPI, PyPy. So there is never a downside to use no index. Okay, so this warning put aside, on your machine, UV, I think, is great. So the first thing, of course, is to install it, but that's really easy because there are a ton of methods. You can even install it with curl or wget. So you can install it from the command line on any system super easily. But of course, you can also install it from the Python package index, so either using pipex or even pip. And then you can use it using Cargo or Homebrew or Winget or all of the window type tools or from Docker or directly from GitHub or from your Linux package distribution manager. So very flexible, easy to install, and works on all platforms. Now, there is no man page, which I found a little bit unsettling at first. And so hopefully you can see my terminal here. I am in a little temporary directory that is empty, as you can see, and I will do everything for this course in here. So if you want to get some help, don't try to use man, but run either UV, and it will list all of the commands and options, or you can run UV with the H flag. It does the same thing, or it tells you to use UV help for more details. Well, maybe on some system, UV help actually gives more details. On my system, it doesn't. Or you can use UV with the help flag. Again, maybe on some systems, all of these lead to different outputs, but on my system, I get the same thing with any of these commands. But if you want more information on one particular command, because UV is a little bit like Git, you know, with Git, there is Git this, Git that. Well, same thing with UV. There's UV with a lot of subcommands that are listed when you run UV, UV help, etc. And those subcommands are run, init, add. So if you want to get a list of the flags for one of those subcommands, you can use the H flag. Or if you want an actual man page like help documentation, you can use UV help and the name of the command. So for instance, init is the command to initialize a Python package or a project. So if I run UV init with H, I'm gonna get the particular flags for UV init. So these are the usage with argument, and then all of the options for the cache, for Python, for all the things. But if I run UV help and then init, now I get into a pager, and I have really something that looks like a man page with some explanation and a lot of details and use cases and examples, etc. Now, also, the best starting place is really to look at the UV website. And one reason I am very hopeful that UV might be the one tool that will stop this chaos of Python tools is that not only it is excellent, but it is also extremely well documented. The documentation is thorough and very good. Alex and I have spotted an occasional error, but they get corrected. And remember, it's a tool that is only a year old, so that they have such an extensive documentation already is actually pretty impressive. So if you are stuck in a rut, meaning you already have a workflow with the classic PEEP tools, and you can't really change your workflow, or you don't want to because like you've set your stuff, well, be happy because there is a drop-in replacement. That I don't think this is the best way to use UV, and if you're starting a new project, a new setup, a new workflow, I don't recommend this. But if you already have something set in place, the drop-in replacement makes it just super easy to replace VNV and PEEP, etc. by UV. Instead of using PEEP, for instance, you will use UV PEEP. Note that UV PEEP does not run PEEP. It is compatible, or at least they strive to make it as compatible as possible. And they say that normally it should just work to replace UV PEEP in your workflow by PEEP. But it doesn't run PEEP or VNV under the hood. They rewrote the whole thing, just so you know. So to create a virtual environment, you will just use UV VNV. And if you want to create a virtual environment with a specific Python version, you can also set that in the command, and it will automatically do it. And note that if Python 3.12 is not installed on your machine, UV will automatically install it for you. So actually, let me just run a few commands just so that you can see how fast things go. So UVVN, it just created it. And so now if I run, it is by default called .vn, so it's hidden. And if I run, let's say right. So this is the end. And as you can see, it has a classic virtual environment structure. So you're not going to be in a very weird new system, but there are a number of things that will look a little bit unfamiliar. So first of all, there is the classic activate that you can find in a normal Python virtual environment to activate it. But they have also written some activation files for fish and C shell and other things, so that if you use some fancy fish terminal, fish shell, instead of bash or Z shell, for instance, well, you can, yeah, okay, the size a little bit bigger, sure. Yeah, so you can activate the virtual environment in various ways. Also, the Python version used will link to the Python that I have previously installed with UV. Of course, that can be customized, as I said, by putting a Python specific version. Also, there is automatically a .gitignore that is added, so that this will not be added to Git if you are in a repository put under version control. So there are a few little convenience. Let me make this actually a teeny bit smaller. Right, just let's find a compromise. Okay. So you can then activate, of course, this virtual environment, but as long as you use UV commands, you actually don't have to. So if I want to now install some packages inside that virtual environment, I don't have to activate it if I use uv pip, because that's a uv command, and I can just run uv pip install the way I would normally use pip install. And you can use exactly the same syntax you're familiar with, so you can install from a repo, from a requirement file, from a Python project file, from a specific commit of a GitHub repo, or from a specific branch of a GitHub repo. All of your usual workflow is there. It's just a lot faster. You can also similarly freeze your packages to create a requirement file. You can list them, you can uninstall packages. So it's just really very simple. But I don't want to dwell on this. Let me clear that actually. So I don't want to dwell on this pip drop-in replacement, because I don't think this is the best way to use UV. This is just a convenience if you're stuck in your workflow. Now let's go into the real UV usage, let's say. So let's talk about Python versions. There is, as I mentioned, an automatic installation. So if you ever require a specific Python version while you create a virtual environment or a project or anything, it will be automatically installed. But you can also explicitly install a specific Python version by giving its version or some requirements that need to be respected. And by default, the implementation that is used is CPython. But if you want to change that, you can also mention it. So easy and flexible. And then you can list your Python versions. So let me run this to show you what I have, for instance. Well, let's make this full screen. So the default Python version that is used by my system, so that I installed that with my Linux package manager. You can see they're over here. So Python 3.13 is what I'm using as my system Python. Now I did install Python 3.12, and it has been installed by UV, so it is stored in my home local directory under share UV, and it is the CPython implementation of Python 3.12. Now you can also see the available options. So you can install alternative options, packages if you need to, but those are the ones that are most commonly used and the easiest to install, and so gives you an idea of what's available and what you have installed. To uninstall the version, I can just and let me uninstall it because I want to demo everything from scratch. So I have 3.12 installed, as you can see. I can just uninstall it. And I find that quite convenient because I just have to write uv python uninstall 3.12 because I know I have 3.12. I don't have to dig around into my files to figure out that it's actually 3.12.9 that I had. Well, if you use pyenv to install additional Python versions, pyenv uninstall 3.12 would not have worked. With pyenv, you have to put the exact version up to the subversion that you have for the command to run. It's a detail, but it's just it shows that UV just makes things very convenient at all levels and in every step. So the key cool thing I find is to use Python projects. So projects are a thing in a lot of languages. For instance, in Julia, if you install the equivalent of a virtual environment, it's in fact a project, and you end up with a project.toml file that will list exactly the dependencies that you have explicitly requested with their version and etc. It doesn't list all of the packages that end up in your project. That's really convenient. So Julia is a beautiful project system, and a lot of languages have that, but Python by default doesn't, and with pip doesn't. So this really replicates this, and it kind of recreates also the cargo system, because the developers of UV come from Rust. They've been extremely inspired by Cargo, which is the Rust package manager in their design. But again, like my experience is more with Julia, and this ends up being very similar to playing with Julia. So I deleted everything I had in my temp directory. So like you can see, it's empty again. So if I want to create a project, I run UV init and then the name of some project. And here again, I can, if I want, create one with a specific Python version. And again, if I don't have that version, it's going to be automatically installed. I can also add a number of flags to remove a number of things, because by default, it will create an entry for a description of the project and a README and things that might be convenient for projects that you want to put out there open source. But for my work, it doesn't do anything. So I actually have an alias for this last one so that I don't have to have those little unnecessary little things in the way. So now that I have this project, we can see what got created. So ESA is just an equivalent to LS that is a little bit nicer with more options. But so I'm just running some equivalent of the tree or LS utilities here. Don't let this distract you. So in my project that got created, I have a .python version file that sets the Python version. I have a main.py file that I don't make any use of, but that can be convenient if you want to have this script run your entire project. There is a README. Again, I don't make any use of that. But what is cool is that there is this pyproject.toml file, and if I look at it, again, don't let bat distract you. It's just a cat replacement with syntax highlighting. That's all. So in this pyproject toml file, I can see that I have a number of things set up. So here, so far, the only thing that's useful is that we know that it requires at least Python 3.13, because that's the only Python version I have installed at this point, since I removed Python 3.12 I had. And so that's my system default. So that's the version that got used. But dependencies is empty. So for now, it's not very useful, but it's there. Now, if I want to add dependencies, I could, of course, create a virtual environment with UV pip install, as with like UV venv and then UV pip install, as I mentioned earlier. But that was just a drop-in replacement. If you're stuck in some workflow, that's not the best way to use it. The much better way to go about it is to enter your project. So cd my project in my case, and then use UV add and whatever dependency you want. Here I just threw in polars and matplotlib. So the a virtual environment called .venv is automatically created, and those dependencies got installed. And notice that I didn't have to activate the virtual environment because I am using a UV command. And as long as I use a UV command from a UV project or from a location where there is a .venv environment, UV knows what to do. So even when you use the drop-in replacement with UV venv and then UV pip install, the default virtual environment created is .venv, and if you don't change that default, it's the same thing. You don't need to activate the environment. UV commands will know what to do. So let's look at the content of my project again. Now, in addition to the elements that I had previously, there is a .venv. So that's my virtual environment with polars, matplotlib, and all of their dependencies. And I have this UVlock. So the UVlock is a file that tells UV exactly what package I have at what version. And it's really useful to put it under version control and to share it with people and to include it in your project for replicability. It means that if now I run a bunch of code and I want someone to replicate the same code and ensure they have exactly the same Python version from the same implementation and the same dependencies at the same version, etc., I just share that UVlock and they can recreate it and rerun it in the exact same conditions. So it's really convenient and easy. And now, if I look at that pyproject.toml file that I looked at before, the dependency sections, which were empty before, now are populated by the packages that I installed. So this is really extremely similar to what Julia does. Julia also creates a project.toml file with the dependencies that you install. And that's something that pip doesn't do. Like with pip, if you install matplotlib and polars, they will be installed along with like 25 or more of their dependencies. And then, yes, you can create a requirements.txt file to recreate that environment, but the requirement will have all of the packages at the same level, the ones you explicitly installed and their dependency. And it's not super convenient, frankly. Like it's unclear what you explicitly installed, what you wanted, what you needed. I think this is really much nicer. If you want to see the dependencies that you have explicitly installed without looking at your PyProject file, you can also run a UV-tree command, and that will give you those dependencies. Now, of course, you can also run a UV piplist, which is the equivalent of piplist and will give you all of the dependencies. So that's my matplotlib and polars that I installed, but also their dependencies. It's just that with pip, that's the only thing you have. You cannot discriminate between the two. Then if you want to update the dependencies both in your PyProject and also in your UVlog file, if you want to keep your project up to date to the development of packages, there are UV sync commands that allow you to do that. And you can, there's a lot of subtlety if you want to get into it to sync and update and keep things up to date up to a certain point, because they really focus on not breaking things and replicability. But if you just want to put everything up to date to the latest version of all of the packages available, of course, dealing with potential conflicts that could be like taking the resolution of dependencies into account, UV sync -u is the command that does it all. And obviously, you can remove dependencies. So you might not be super impressed so far, because first, I've been very messy in my explanation. I got distracted by the terminal size, and I didn't sleep much last night. So you might not be convinced, and you'll be like, okay, yeah, big deal. So now I'm going to show you why I think this is a big deal. So let me clear everything. I'm doing that on the side window. So I'm starting again from scratch in here. Let me show you how fast it is, because yeah, this might be what convinces you. So I don't have any Python 3.10 out there. The only Python that I have currently on my machine is 3.13. I had 3.12 earlier, but I uninstalled it. So if I want to install Python 3.10 because I need it for some project or other, the classic tool is pyenv. So I can run pyenv install 3.10, and it will download a tar, a zipped tar file. I mean, like a compressed tar file, and then it will install it. And yeah, like this is time for a coffee break. Like it's not fast. So you'll tell me, okay, well, big deal. Pyenv, it's slow. It takes forever to install a Python version. But well, like how often do you need to install Python version? Once you have installed a handful of Python versions you need, you're set. So wow, no big deal. But I think it is an inconvenience. Oh, and look, by the way, look at my CPU usage that is over here reaching 100% now. So not only it takes forever, but it's like, and I was using 100% of my CPU usage also when I wasn't using Zoom. So this is not a side effect of Zoom. It's just slow and CPU intensive. So the downside of that is that you might think twice about installing a bunch of Python versions and testing things. It's not an insane inconvenience, but it's limiting. If you want to, explore a lot of things, like my CPU went back to 100%. If you want to test a bunch of things for whatever reason, and in deep learning with all the dependencies and all the things that work on one version or another, but not on the version you have, like it can really be useful and necessary to install a lot of Python version. Well, this is, yeah. So there we are, like we're waiting.
Okay. Mary, one quick question. So for I'm reading the instructions. I went to the website, and there is something that calls my attention because you might be familiar with this. It's when you install locally CUDA, it's a pain. And there is several modifications that have to be done to your environment. And there is one message here that says disabling shell modification. So it says the installer may also update your shell profiles to ensure the UV binary is on your path. So probably that's something I wanted to know.
Okay, yeah, I don't know. We can discuss it at the end. I would like to get to the end of the webinar if I can in the last 20 minutes, and then we can chat about that.
Okay.
Because finally, no, that was a great time because we were stuck, but finally, Pyenv did its job, and I have 3.10 installed, and it got installed in my home directory .pyenv subdirectory. This is where Pyenv stores its Python versions. Okay. So now let's do the same thing for the sake of comparison with UV, because now I do have Python 3.10, but I want to install, create a totally different installation of Python 3.10 that's going to go in a totally different place. It's going to go in UV spatial location for Python versions. So I'm running the same thing, and that's it. So yeah, that's the time difference, like 1.69 seconds. And yes, UV brags about how quick it is, but I think they can, because you see the difference. So no big deal, you'll tell me, but it's just so much faster. Now, let's compare the timing for PEEP versus UV PEEP, because we just saw that for Python versions, the time difference is mind-blowing. Let's do the same thing here. So with PEEP, I will create, following the classic workflow, a virtual environment. So I'm using my default Python version here, so Python 3.13, and I'm calling it .vm. So, okay. So that takes some time. But okay, then I have to source it. Then I update PEEP. That takes a little time, but it's not too bad. And then I install one package. It's JAX AI Stack, and I chose this one because it's a meta package. It's a package that combines JAX and flags and optags and orbags and a number of things. It's a very convenient way to run JAX for deep learning because it automatically installs a bunch of dependencies. And note that I am not installing Torch Vision and JAX for the GPU and things like that, because otherwise we would be sitting here for an hour. But so yeah, it did it. And so now you can see that I have my virtual environment over here. I'm going to destroy this virtual environment. Of course, I have to deactivate it. So I've cleaned everything, so I'm back to 0. Let me now show you the equivalent with UVPip to get a sense of the difference in time. So to create a virtual env, I run UVVenv. That's quite a bit faster. And then I install the same package. So it's not instant. It does take a little time, but it is just much faster. The difference might be a little bit striking compared to PyEnv. PyEnv is particularly slow, but it's still a lot faster than pip. So that's it. It's done. It's over here. So let me delete it again. So another thing, I shouldn't have deleted it to demo this, but that's okay. Once I have this virtual environment, I can launch Jupyter from it, or I can run scripts from it. I can do all sorts of things without ever activating it, as long as I run UV commands. And the UV command to run things is UV run. So UV run with a script, or UV run with Jupyter if you want to run Jupyter Lab. So I can launch from there any number of things. I could run UV run IPython, for instance, to launch the IPython shell using that virtual environment. Now, the reason I discovered UV, as I mentioned, is because of a particular use case. So I needed Python 3.12 because of one of the packages called Grain that I wanted to install, and it's still stuck at 3.12 because it depends on TensorFlow, which is stuck at 3.12. So I need to install Python 3.12, create a virtual environment, and then install a number of packages. So with the classic tools, I need to first install Python 3.12 with PyEnv, which, as we saw, takes a while. Then I need to create a virtual environment with that Python version. So first I need to fish out for that path. It's not that hard once you know where it is, but it's you have to go find it, and then you create the virtual environment. But instead of using Python as we did earlier, I'm now using the home.pyenv version, etc., etc. So that's the Python that pyenv installed with 3.12. Then I have to activate it, update pip, and then install my packages. With UV, using a Python project, I can directly initialize a project with and have Python 3.12 directly installed by adding this flag. So it creates a project and it installs 3.12 all in one go real quick. I CD into it, and then I can add my dependencies very quickly. And then not only it's simpler and much faster, but that also leaves me with this Py project TOML file with all of my dependencies listed here, and a UV lock that, again, I can put under version control, share to make my code perfectly reproducible. So I just thought that was a lot simpler, a lot faster, and that convinced me to start using UV. Now, it's also a replacement for pipx, because there are a number of Python tools that people use, and by tool, people mean their convenience utilities. For instance, a Python formatter, a Python linter. So there's like Flake and Black and Rough, which is written in Rust and developed by the same people who wrote UV. And those are not required by the code. So that's not something that you want to have within a specific virtual environment, if not needed. And also it's something that you normally use across your virtual environments. It's something that you use all the time. And so you could install such things in every single of your virtual environments, but if you then share those virtual environments with other people, they may have different preferences for their linters and formatters. So it's not a very good practice to have such tools in virtual environments. So people tend to install these tools with either their Linux distribution package manager, that's what I do, or Homebrew if you're on Mac, or Pipex. Pipex is a good tool for that sort of stuff. But UV can replace Pipex and use it. So if you want to install Rough, which is a linter, good, fast, and efficient, you can run UV tool install Rough, and it will install that tool globally on your machine, and then it's going to become available to you across any of your virtual environments. But what is kind of cool is that you can even use tools without installing them. So, okay, they actually do get installed, but because UV installs everything so quickly, it's like tick, tick, like it doesn't take any time. And it gets installed in a temporary directory that will then get cleared up. So if you want to test a number of tools, or if you need one tool on occasion for one script and you don't want to have it on your system permanently, you can just run UVX and then the tool, and that will just run it for that one time. UVX is an alias for UV tool run. And if you look at the website, you will see a number of things that I'm not presenting here because I really wanted to stick to what I thought was the most useful in research computing. But if you're into software development, or if you have different workflows, there are a number of things that that is out there that can also be very convenient. In particular, running scripts. You can add into scripts dependencies as commented lines inside your script. And you can then run your scripts even if you don't have the dependencies installed on your machine. So for instance, this over here. So that makes your script self-contained, and the dependencies that will be installed to run the script will, as with UVX, be installed in a temporary directory that will then get removed afterwards. So if you don't want to have these tools installed, or if you don't want to create a virtual environment just for a particular script, or if there is a script that you use regularly without being in one virtual environment or another, you can just put that. And because UV is so fast, the downside of having those dependencies installed is actually nil, because the first time it will be very fast, but it will still take a teeny bit of time. But because UV has this central cache, once it has done some caching, the dependencies will be installed like quasi instantaneously, and your script will run without having to worry about creating and activating a virtual environment and all that. You can also do the same thing from the command line by using the with tag, and so you can do some UV run with the tag with and then a number of dependencies and then your script, and it will lead to exactly the same thing.